Hello everyone, this is Lucas Usmel and I am the corresponding author of the paper entitled The Strain Energy Density to Estimate Lifetime of Notched Components Subjected to Variable Amplitude Fatigue Loading. This paper was prepared in collaboration with Dr. Zheng Hu and Professor Filippo Berto. The aim of this paper is to show that the strain energy density approach can be extended to those situations involving notched components that are subjected to variable amplitude uniaxial fatigue loading. The strain energy density approach takes as a starting point the idea that damage can be estimated by averaging the strain energy density over an area in the vicinity of the assumed crack initiation point. In this context, the radius of the area is assumed to be a material property which is different for different materials. In order to extend the use of the strain energy density approach to those situations involving variable amplitude uniaxial fatigue loading, what we can do is simply reinterpreting the strain energy density approach according to the classic solution due to Palmgren and Miner. In particular, for any strain energy density level, we can calculate the associated damage so that the total value of the damage sum can be calculated by considering the contribution coming from the different cycles forming the load spectrum being investigated. In order to check the accuracy and reliability of this extension of the strain energy density approach, we consider some data we generated a few years ago by testing cylindrical samples of carbon steel C40 under uniaxial variable amplitude fatigue loading. So these two graphs show the overall accuracy we obtain in the first case by applying by using a critical value of the damage sum equal to 0.63, which is the critical value that can be calculated from the uniaxial plane samples, and also using a critical value of the damage sum equal to unity as postulated by Palmgren and Miner. In conclusion, we can say that the proposed formulation of the strain energy density approach is capable of estimating fatigue lifetime of notched components subjected to variable amplitude uniaxial fatigue loading. And as expected, this formulation of the SED is seen to be sensitive to the critical value which is used to estimate failure in terms of total damage sum.